Hello, curious minds! Previously we explored the possibilities of terraforming Mars. If you haven't seen it yet, we've linked it in the description below, so be sure to check that out after this video. Today though, we're turning our attention to Venus, Earth's fiery twin. Could we ever make it habitable? Let's find out. Now you might be wondering, why Venus? When we think about colonizing the cosmos, Mars often takes the spotlight. So why not stick with a planet that at least on the surface seems a bit more manageable? Well, for starters, Venus is practically in our backyard. It's our closest planetary neighbor, coming as near as 38 million kilometers or 24 million miles to Earth. In comparison, Mars is farther, with a closest distance of 54 million kilometers or 34 million miles. This shorter distance could make Venus easier to reach and resupply in the future. But proximity isn't the only perk. Venus shares some striking similarities with Earth. It's often called Earth's twin because it's nearly the same size with about 95% of Earth's diameter and 81% of its mass. This means Venus has gravity closer to Earth's, about 90% of what we experience here, compared to Mars' weaker gravity at just 38%. Why does this matter? Well, stronger gravity is better for maintaining a human-friendly atmosphere and preventing long-term health issues like muscle and bone loss. Imagine going for a jog on a terraformed Venus, feeling the pull of gravity that's remarkably close to what you're used to on Earth. Venus also receives twice as much solar energy as Earth due to its proximity to the Sun. This makes it an excellent candidate for solar power, which could sustain future colonies or terraforming projects. Now, while the surface of Venus is an uninhabitable inferno, there's a silver lining, literally. About 50 kilometers or 31 miles above the surface has temperature and pressure conditions remarkably similar to Earth's. This makes it an ideal location for future exploration, or even habitats floating above the planet's surface. Another fascinating aspect of Venus is its potential for resource extraction. Venus's surface is thought to be rich in minerals, including basaltic rocks formed from volcanic activity. There's evidence to suggest the presence of metals like iron, nickel, and perhaps even rare metals like platinum group elements. And here's another potential advantage. Venus's atmosphere, though toxic, is rich in carbon dioxide, a potential resource for creating oxygen and fuels. If we can harness it, the atmosphere itself could be a valuable asset. But perhaps the most compelling reason to focus on Venus is that it holds the key to understanding the dangers of climate change and planetary evolution. Exploring it could teach us not just how to terraform, but how to better care for our own planet. So, Venus may have some promising qualities, but let's not sugarcoat it. It's one of the most hostile places in the solar system. So, what's standing in the way of transforming this inferno into a livable world? Let's dive into the challenges of terraforming Venus. First up, the temperature. Venus's surface averages around 475 degrees Celsius or 900 degrees Fahrenheit, hot enough to melt lead. That's thanks to a runaway greenhouse effect caused by its thick, carbon dioxide-rich atmosphere. Any terraforming project would need to tackle this extreme heat. Next, there's the pressure. Venus's atmosphere is so dense that standing on its surface would feel like being 1 kilometer or 0.6 miles underwater on Earth. At 90 times the pressure of Earth's surface, even the toughest human technology struggles to survive. And let's not forget, Venus has virtually no liquid water, a vital ingredient for life as we know it. Its water may have evaporated billions of years ago, making it extremely dry today. Now let's talk about its atmosphere. Venus's atmosphere is 96% carbon dioxide, with clouds of sulfuric acid, a mix that's not only unbreathable but also corrosive. Any structures built there would need to withstand both chemical and physical extremes. Another problem is that Venus spins so slowly that one day on Venus is longer than a year, 243 Earth days long to be exact. This presents major challenges for maintaining livable conditions, as long periods of sunlight and darkness could cause extreme temperature swings in any future terraformed environment. Plus, Venus is home to thousands of volcanoes, and while its current level of volcanic activity is debated, the planet's geological instability could pose significant challenges for long-term infrastructure. And unlike Earth, Venus doesn't have a magnetic field to protect it from solar radiation. In fact, sensitive spacecraft measurements show that any magnetic field Venus might have is at most 1/8,000th the strength of Earth's. This means solar wind continuously erodes its atmosphere and exposes the surface to harmful radiation. And here's a question to ponder. Would we risk disrupting the solar system's delicate balance in our pursuit of a second home? Terraforming Venus is no small feat. But scientists and visionaries have imagined some extraordinary concepts to tackle its challenges. From planetary-scale engineering to harnessing the power of nature itself, let's dive into the wildest ideas for transforming Venus into a second Earth. One of the first steps in terraforming Venus would be to cool the planet down. One proposed method involves placing giant reflective sunshades in orbit around Venus. These shades could block sunlight, reducing the planet's temperature and potentially halting the greenhouse effect. Alternatively, orbital mirrors could redirect sunlight away from Venus or even reflect it to other parts of the solar system where it's needed. These mirrors would need to be massive, spanning thousands of kilometers. Since Venus's thick atmosphere is mostly carbon dioxide, thinning it out would be a game changer. One idea is to chemically bind the CO2 into solid compounds, such as carbonates, by introducing reactive elements like magnesium or calcium. But where would we get those materials in such quantities? Another idea involves introducing microorganisms or genetically engineered algae to the atmosphere. These organisms could theoretically convert CO2 into oxygen over time, much like plants do on Earth. While this concept is far from practical right now, it sparks fascinating possibilities for using biology as a terraforming tool. Some have even suggested using powerful lasers or orbital technology to strip away Venus's atmosphere into space, gradually reducing its density over thousands or millions of years. Venus's lack of water is another major problem, but one idea is to redirect icy asteroids or comets to crash into the planet's surface, just like the proposals for Mars. This would deliver water and potentially cool the planet at the same time. Of course, the energy and precision required make this a monumental challenge, and Venus lacks a magnetic field too to protect it from solar radiation, but some have suggested creating an artificial magnetic shield at its Lagrange point. This shield could protect the atmosphere while enabling long-term habitability. Now here comes the crazy part. Instead of changing Venus, what if we adapted to it? At an altitude of about 50 kilometers or 31 miles, Venus's atmosphere has conditions similar to Earth's. Floating habitats or cities could thrive in this zone, using the thick atmosphere as a natural buoyancy aid. So, when can we pack our bags and book a one-way trip to Venus? Well, hold your horses. Cooling the planet alone could take hundreds to thousands of years. The greenhouse effect on Venus is so entrenched that reversing it would require sustained intervention over centuries. Even with advanced technology, lowering the planet's temperature to habitable levels could take 1,000 years or more. Thinning Venus's dense CO2 atmosphere would be another monumental task. Whether through chemical reactions, biological processes, or physically removing it into space, this process would span thousands to tens of thousands of years. And that's assuming breakthroughs in technology that don't yet exist. Redirecting comets or asteroids to deliver water would take precise navigation and immense energy, not to mention centuries for the impacts to accumulate enough water for a stable hydrosphere. If hydrogen bombardment were used instead, we'd still be looking at a timescale of many centuries. Placing sunshades or orbital mirrors around Venus would require constructing structures spanning thousands of kilometers, far larger than anything we've built in space. The logistical and material challenges are staggering, and introducing microorganisms to alter the atmosphere assumes we can engineer life forms capable of surviving Venus's harsh conditions, including its acidity and temperature. This level of bioengineering remains purely theoretical today. The energy needed to move comets or asteroids, power atmospheric stripping, or sustain magnetic shields would dwarf anything humanity has ever generated. Even harnessing solar power on an unprecedented scale would face major hurdles. Terraforming Venus would require not only global cooperation, but also enormous financial investment. Sustaining such a project for thousands of years would demand a level of unity and commitment that humanity has never demonstrated. While transforming a planet is an extraordinary idea, there are other strategies that could bring us closer to living beyond Earth. Let's explore some alternative approaches to Venus and what they could mean for the future of space colonization. We talked about floating cities, but Venus doesn't need to be a second Earth to be valuable. It could serve as a base for research into extreme environments, climate change, and planetary evolution. Additionally, its dense atmosphere and mineral-rich surface might hold untapped resources for future technologies or off-world industries. And why limit ourselves to planets? Orbital habitats like O'Neill cylinders or Stanford toruses offer the possibility of creating controlled, Earth-like environments in space. These structures could orbit Earth, Venus, or other celestial bodies, allowing for a flexible and modular approach to colonization. Looking even further ahead, humanity might eventually venture beyond the solar system. Concepts like generation ships or terraforming exoplanets bring us into the realm of speculative fiction, but who's to say what the future holds? Plus, space colonization isn't just a technological challenge, it's a human one. Successful colonization will require unprecedented levels of international collaboration, pooling resources and expertise from across the globe. So, what do you think? Is terraforming Venus a crazy dream or a future reality? Would you prioritize Venus over Mars, or do you have a favorite planet for humanity's next frontier? Let me know in the comments below. If you enjoyed this video and want to see more like it, don't forget to give it a thumbs up and subscribe to our channel. And if you're curious about terraforming Mars, check out the video linked in the description for more fascinating ideas about humanity's future among the stars. Thanks for watching. Until next time, keep looking up.